Permeable interlocking concrete pavements with Rapid Clean Technology Part 2. Previous research and 20 years experience taught us that the current generation of permeable interlocking concrete pavers can have some maintenance issues. See our Part 1. Were not cleaned regularly and diligently, over time, the infiltration rate of a permeable pavement diminishes significantly. Most standard cleaning methods show limited effect. Reason lies in the design of the current generation of PICPs. To quote Jennifer Drake, a researcher from the University of Toronto, the lack of proven cost-effective and practical approaches for permeability restoration prevents the widespread adoption of PICP systems in North America. Novel and practical maintenance and operational methods supported by scientifically based proof of effectiveness are needed. Rather than enforcing unrealistically strict maintenance schedules and expensive special equipment to maintain current PICPs, we developed a new system by redesigning the paving stone shape and joints, specifically with maintenance in mind. The key performance objectives during the development of our Rapid Clean technology were intended for all traffic loads, offer infiltration rates of at least 10 inches per hour equal to the original Uni-Group stone, be fully ADA compliant, less than half-inch joint width, successfully pass most rigorous cleaning trials. Here are the schematics of the design approach. Take typical concrete paving stone, here in top and side view, and incorporate channels or conduits along the sides. Create special concave openings along the top of the paving stone, called cupules. Here is one of them. Fill the conduit and cupule with drainage aggregate. Now pressurized air or water would be able to rapidly dislodge sediment and debris and facilitate easy cleaning of these cupules. Also, brushes and bristles can now dislodge debris rapidly. So what is a cupule? Cupules are concave natural or man-made depressions on the surface of rock or stone. A test rig was constructed and set up at the University of Guelph laboratory to model the vacuum head of a typical regenerative air street sweeper. So much for the theory, now the test trials. We tested many different cupule designs to find the best performing one. As seen, they would vary in depth, width, angle, and contour. For the final version, the cupules are formed to fully comply to ADA guidelines, having a maximum gap less than half-inch wide. On first glance, this CAD drawing may look complicated. The rendering on the right better shows the final pavement. Here you see the production of the first pavers. Field testing commenced in Ayr, Ontario, November 2016, utilizing a 20 by 40 foot section of an existing permeable parking lot. To set a benchmark, the initial infiltration rate of the existing permeable pavement, the existing bedding layer ASTM number 8, and existing granular A base were tested using the ASTM C1781 infiltration test. Then the new Rapid Clean pavers were installed. Next, the cupules and joints were filled with drainage aggregates in various gradations. Here, a close-up of empty and filled cupules and joints. Now, the full-scale cleaning test started using a large regenerative air sweeper, a mid-size rotating brush sweeper, a small walk-behind power brush, and a portable handheld blower. Visible here is the removal of sediment from within the cupules. Further infiltration tests after 3, 6, 9, 18, 24 months were conducted. These tests demonstrated that after each cleaning, even when only using just medium and small motorized brushes, the infiltration rates could rapidly be regenerated to the initial levels of between 100 inches per hour and 500 inches per hour. Of note is the industry recommended long-term infiltration rate is to be above 10 inches per hour. Test results were published in several peer-reviewed research reports, journals, and on Stormwater Conference. Links can be found on our website. In summary, findings showed that this new permeable interlocking concrete pavement can maintain or restore the infiltration rate rapidly using readily available maintenance equipment, even simple handheld tools. The cleaning speed goes up and the maintenance cost goes down. Moreover, cleaning intervals could be extended as cleaning becomes simpler, even when clogged. While all PICPs are intrinsically beneficial, This new Rapid Clean permeable pavement system gives added confidence that even neglected or delayed, maintenance can now be performed easily when required or mandated. Besides the acknowledged benefits of PICPs, such as better aesthetics, high traffic loading, easy access of underground utilities, low life cycle cost, these major savings in maintenance costs for municipalities and facility owners will provide new opportunities for the use of permeable interlocking concrete pavements. For additional information and availability, contact www.uni-groupusa.org.